Question 8, Part B. PQRS is a rectangle with PQ equals 6 centimeters and QR equals 4 centimeters. T and U lie on the lines SP and SR respectively, so that T, Q and U are collinear, as shown in the diagram. Let PT equal X centimeters and RU equals Y centimeters. Part 1. Show that triangles TPQ and QRU are similar. Since PQRS is a rectangle, this means all angles inside the rectangle are 90 degrees. So this is 90 degrees here, 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 and here. This implies that angle TPQ is 90 degrees, since this angle plus this angle must equal 180 degrees, since they lie on a straight line. This is the line TPS. So angle TPQ is 90 degrees and angle QRU is also 90 degrees. Now also, PQ is parallel to SR, since opposite sides of a rectangle are parallel. Now S, R and U are collinear, so this means they lie on the same line. So by extension, PQ is parallel to SU. So here's PQ and here is SU. This means that TQU, or just TU, is a transversal on parallel lines PQ and SU. And this means that angle TQP is equal to angle QUR because they are corresponding angles on parallel lines PQ and SU. So looking at triangles TPQ and QRU, we have two 90-degree angles that correspond, and we also have two other angles that correspond. So therefore, triangle TPQ is similar to triangle QRU, and the test is equiangular or angle-angle. Part 2. Show that XY equals 24. Since triangle TPQ is similar to triangle QRU, corresponding sides are in the same ratio. So going back to the diagram, that means X over 6 in triangle TPQ is equal to 4 over Y in triangle QRU. And we can form this equation. X over 6 is equal to 4 over Y. So by cross multiplication, we get XY equals 24 as required. Part 3. Show that the area A of triangle TSU is given by A equals 24 plus 3x plus 48 over x. The area of triangle TSU is equal to half times the base times the perpendicular height. Now, the base of triangle TSU is the side SU, which has length 6 plus y. And the perpendicular height, TS, has length x plus 4. So area is equal to half times the base times the perpendicular height. Substituting 6 plus y for the base and x plus 4 for the height, we get area is equal to half times 6 plus y in brackets times x plus 4 in brackets. Expanding the brackets, we get area is equal to half times open bracket 6x plus 24 plus xy plus 4y close bracket. Now we want the area in terms of x, not in terms of x and y. So we need to express y here and here in terms of x. Now, given that xy is equal to 24, which we've shown in part 2, we can replace the xy here with the value 24, and the y here can be replaced with 24 over x. Now, we get that by rearranging this equation here and making y the subject. And that's why we have y is equal to 24 over x. So the area in terms of x is equal to half times open bracket 6x plus 24 plus 24 plus 96 over x, close bracket. Now 24 plus 24 is 48. So the area A is equal to half times, open bracket, 6x plus 48 plus 96 over x, close bracket. So multiplying through by half, half of 6x is 3x, half of 48 is 24, and half of 96 over x is 48 over x. Therefore, the area A is equal to 24 plus 3x plus 48 over x as required. Part 4. Find the height and base of the triangle TSU with minimum area. Justify your answer. The area A with respect to x of triangle TSU is given by the equation A equals 24 plus 3x plus 48 over x. Now we want to minimize A, which means we want to find a value of x which gives us the smallest possible value of A. And in order to do that, we need to differentiate A with respect to x. In order to make the differentiation a little easier, we can express this term here, 48 over x, using a negative index. So the area A is equal to 24 plus 3x plus 48 times x to the power of negative 1. Differentiating A with respect to x, we get A dash is equal to 3 minus 48 times x to the power of negative 2, which is 3 minus 48 over x squared using a positive index. Next, we solve the equation A dash is equal to 0. That is 3 minus 48 over x squared is equal to 0. Multiplying all terms by the denominator x squared, we get 3x squared minus 48 is equal to 0. Moving the negative 48 from the left-hand side over to the right-hand side, it becomes positive, so we get 3x squared is equal to 48. Dividing both sides of the equation by 3, we get x squared is equal to 16. And taking the positive square root of both sides of the equation, since x represents a length, so it must be positive, we get x is equal to 4. Next, we need to show that x equals 4 minimizes A, and we can use the second derivative to show that. Now, the first derivative, A dash is equal to 3 minus 48 times x to the power of negative 2. Differentiating A dash with respect to x to get an expression for the second derivative, we get A double dash is equal to 96 times x to the power of negative 3. Now when x is equal to 4, the value of A double dash is equal to 3 over 2, which is positive. Hence, x equals 4 minimizes the area A. Now, given that xy is equal to 24, when x is equal to 4, y is equal to 6. So the base of triangle TSU is equal to 6 plus y. Now y is equal to 6, so the base is 12 centimeters. And the height of triangle TSU is x plus 4. Now x is equal to 4, and 4 plus 4 of course is 8. And that's the height of triangle TSU. Therefore, the height and base of triangle TSU with minimum area has a base of length 12 centimeters and a height of 8 centimeters.